Hey guys, so here's the answers to the sheet due today. And good news, I'm not going to give you anything due tomorrow because the next phase or next step to this empirical molecular business, um, we have to really understand what we're doing here first to do the next type of problem. So we'll make that due Thursday. So tomorrow in class, I will maybe go over another um, problem like the one at the bottom of this page or the ones on the other sheet, and make sure you kind of get the gist of that. Then I'll show you the next couple problems that you would have to do based on empirical molecular, and then give you a few problems or a worksheet due Thursday. And then Friday, I might wait to go over that on Friday. I don't know. We'll see. And then Friday we'll start a new unit called kinetics. So we're moving along here. So, anyways, here's the answers to this. So, ethene. Here, let me zoom in here. Ethine. That's how you say that. Ethine reduces to CH. CO2 cannot reduce. So CO2. This reduces to BH3. C8H8 reduces to CH. CH2O is the empirical. It's the lowest ratio there. And then CH2O would be the same here. Divide each one by 6. So there you go. That hopefully was not too hard for you. All right. Now let's do this one. Okay. Oh. All right. So here we go. Let's do, I don't know, this one. Okay, and a little bit bigger. Let's go size 2. All right, here we go. Chemists combined 2.23 grams of iron with an unknown amount of sulfur, heated a mixture in a crucible. Iron sulfide was the result. Mass of the empty crucible and lid was 30.25. Total mass of the cool covered containing iron sulfide was 35. What is the empirical? Okay, so Paul asked a question yesterday, how come it's not with ionic? And then here we go, here's an ionic problem. So it's not that ionic compounds don't have empirical, it's just they basically always form in their empirical formulas. Anyways, here we go. So we had Fe plus S, and it yields FeS. Now we're trying to figure out X and Y, these subscripts. That's what we're told, the whole point of this. So it said we combined 2.23 grams of Fe with an unknown amount of sulfur in a covered crucible. So you got your crucible here. That's a great crucible. I can do better than that. Maybe I can't. It's more maybe like this. And then you got a lid on it. Okay, that's not too bad. All right, so inside here, we added the iron and the sulfur, right? So we got Fe and S in the crucible. We know part of this mass is 2.23. All right, so part of the iron and sulfur mass inside. Now, they did tell us that the mass of the empty, so the crucible itself, without the iron and sulfur in it, is 30.25. So that's the crucible, is 30.25 grams. After you put the iron and sulfur in, you heat it. Now you have the crucible with iron sulfide. So here we go. All right, we got our lid here. So in here, we have our compound now. This is Fe plus S, a mixture. Once it heats up and reacts, now you have a compound. So this crucible over here is 34.41. Okay, so empty crucible. So I know this is misleading, the picture, but so here, this is empty crucible, 30.25. So I know I drew the picture, but I'm just trying to kind of do everything at once here. Empty crucible with FeS, 34.41. We want to know the empirical formula of the FeS compound. So ultimately what we need to do is find moles of Fe, moles of S, divide by the lowest number, kind of like you see up here, and then that gives us the empirical formula. So we know 2.23 grams of Fe are in here. Conservation of mass. So part of this mass, 2.23, is Fe. But first, we have to subtract the crucible masses to get the mass of Fe, right? So the crucible with FES, again, is 34.41 grams. The crucible that is empty is 30.25 grams. So we subtract those. 34.41 minus 30.25. I get 4.16 grams. What does that tell me? That is the mass of FES inside the crucible. So in here, the mass of FES is 4.16. All right, so now I'm going to erase all of this because I need more room. All right, so I'm going to erase this. Come on. Erase this. All right, that should be enough room. Okay. Why is that? All right, cool. That kind of stuff makes me crazy. All right, there we go. So we know FES is 4.16 grams. The problem told us the iron is 2.23. So Fe is 2.23. If I subtract those, I will get the mass of the sulfur. So 4.16 minus 2.23, 1.93 grams. By the way, this is a advanced problem. This is more of an AP problem. And again, some of you are probably like, why are we doing this? Well, it's a good skill. It's part of the class as far as this empirical molecular. Also, those of you moving forward in AP Chem need to know how to do this. So, that's why we're doing it. All right. So now it's a Regents problem. If you know the mass of Fe, you know the mass of S, now converting to empirical, that's a Regents thing. So my S is 1.93. My iron has always been 2.23. Again, the total mass of FES is 4.16 when we subtract these two numbers. And again, based on the law of conservation of mass, if you know the compound mass and you know the iron mass, you just subtract to get the S. That's what we did. All right. So now I need a little bit more space here. All right. So now what we're going to do is convert. So my Fe is, here, I'll do this. Fe on this side, S on this side, and then we'll get the answer, the empirical, and put it over here. All right, so we go to the periodic table, which I haven't opened up yet. Sorry. Iron is 56, but again, I like to show you. All right, so there's Fe, 56, and sulfur is 32. So we remember that. So there's 56 grams in 1 mole. We have 2.23. How many moles? And then sulfur is 32 grams per 1 mole. We have 1.93. So how many moles is that equivalent to? So X equals here for iron. It's going to be 2.23 divided by 56. So 0.03, I'm going to keep all those. 98 moles of Fe. Okay, cross multiply and divide there. Okay, and then 1.93 divided by 32. I get X equals 0.0603. Okay, so now to get the empirical formula, we divide by the lowest number of these. So we divide by this, 0.0398. Divide by 0.0398. And this is going to be 1, so it's going to be, it's going to be FES, right? So this is 1 atom of Fe. So a 1 there. Now 0.0603 divided by 0.0398, I get 1.5. So 1 to 1.5. We can't have a 1 to 1.5. And, now in, hindsight's 2020, they say, meaning looking back, this definitely is way too hard for you guys in general. Some of you hopefully could get to this point. Maybe all of you, that'd be awesome. But the reason I'm saying this is too hard is because now you have to understand you can't have a 1 to 1.5. You can't have half of an atom. So what you have to do is you make these whole numbers, but keep the same ratio. So 1 to 1.5 is the same as Fe2S3. 2 divided by 3, or 2 to 3 ratio is the same as 1 to 1.5. So this is not the empirical, this is. Oops, not Fe. Fe2S3. So that was very difficult. If you understand this part here and this part here, converting to moles divided by the lowest number, then you're in a good place. All right, but to get to that and then your final answer is tough. I can see that. So we'll talk more about this tomorrow in class. All right, so there's that. Let me go over the other sheet now. Here we go. All right. Unknown compound containing carbon, hydrogen has been dried and massed in the lab. It's been determined mass of carbon is 36, hydrogen is 9. Determine the empirical. Here we go. So for carbon and then hydrogen, and then we'll get the formula over here. I know carbon is 12 grams in 1 mole. I know hydrogen is 1 gram in 1 mole. And if you're sitting here going, where is he getting that? Again, periodic table. Carbon has a gram form of the mass of 12 moles. 12 grams in 1 mole. Hydrogen is 1 gram in 1 mole, right? 1 gram per mole. So 1 gram per mole, 12 grams per mole. The compound here tells me, or the question tells me the compound has 36 grams. So how many moles is that? 9 grams. How many moles is that? Hydrogen's easy. If you know the grams, you know the moles. So that's equal to 9 moles of H. This cross multiply and divide. 36 divided by 12. X equals 3 moles of carbon. So now we divide by the lowest number, 3. Divide by 3. So I get 1 carbon and I get 3 hydrogens. So it's CH3. That's the answer to number 1. Okay. I know I go fast sometimes. I'm trying to make these videos not so long. You guys can watch them and pause them, obviously, replay them. That's why I'm doing that fast. Okay, number 2, same concept. Convert grams to moles, divide by the lowest number. Okay, compound contains CHO. The total mass is 3. So we have CHO, X, Y, Z. Those are the subscripts we're looking for. We know the total mass is 3 grams. Okay, mass of carbon is 1.2. Mass of hydrogen is 0.2. We have to find oxygen first, right? That's the hint. So 1.2 plus 0.2 plus whatever oxygen is going to equal 3. So really it's 3.0 minus 1.4. Why? 0.2 plus 1.2 is 1.4. So we subtract those and we get 1.6 grams. So that's the mass of oxygen. So we have 1.2 here. I'll put it over here. 1.2 for C, 0.2 for H, and 1.6 for O. All right. So that was the first step. Really wish this erased better. Leaves these little dots sometimes. It's like here we go. So now I need to find moles of carbon, moles of hydrogen, moles of oxygen, and then I'll get my formula over here, CHO, and I'll put in my subscripts. Here we go. Again, 12 grams to 1 mole is equal to 1 gram over 1 mole is equal to, and then oxygen is 16 grams per mole is equal to, here I can make that. Here. All right. Real quick. Hydrogen, 1 gram per mole. Carbon, we just did it, 12 grams per mole. Oxygen, 16 grams per mole. All right. We have 1.2 grams. How many moles? We have 0.2 grams. How many moles? We have 1.6 grams. How many moles? So cross multiply and divide. 1.2 divided by 12. We get X is equal to 0.1 moles of carbon, 0.2 moles of hydrogen, and this is going to be 0.1 moles of oxygen. So 0.1 is the lowest number. So divide by 0.1, divide by 0.1, divide by 0.1. I get 1 carbon. this is 2 hydrogens and 1 oxygen. So it's CH2O. That's the empirical formula. Because the ratio is 1 to 2 to 1. Okay. Next, number 3. Oops. Oh, hold on. Where is it? There it is. Okay, number 3. Here we go. And again, I will do some more. I'll maybe do 2 of these again tomorrow and then teach the new. Once you learn this, you take these types of problems and then I just add on to it, essentially. All right, which sounds fun, right? So a compound with unknown, okay, 3.5 grams of N, 8 grams of O, calculate. All right, so N and O, and then we're going to get NO and an X and a Y. We're going to find the subscripts. Here we go. So I know nitrogen is 14 grams per 1 mole. I know oxygen is 16 grams per 1 mole. And again, some of you are like, don't show us, but I'm going to do it anyway. Nitrogen, grams per mole, right? 14. We already know oxygen, but that's nitrogen. 14 grams in 1 mole. We have 3.5 grams. How many moles? Oxygen, we have 8 grams. How many moles? Here, I know that's 0.5 moles of O. Here, this is going to be 0.25 moles of N. So divide by 0.25, that's 1 atom of N. Divide by 0.25, that's 2 atoms of O. NO2, nitrogen dioxide, a harmful gas released from the combustion of fossil fuels. All right, so there's that. Okay, so hopefully some of that, if you actually watch this and pause it and check your answers and try and learn, then it should be useful. As always, reach out to me, text, email, whatever you need to do, and I can help if you need more help. All right, I'll see you guys tomorrow. No homework or no worksheet due tomorrow. Okay.